Kia. Our fifth tip for learning the organic reactions is to identify the leaving group. So if we look at these examples, thinking of the last tip was to identify the reactive site, where you had to first identify the functional group. We can see we've got an amide over here, a carboxylic acid over there, and an acyl chloride over here. So if you look now, the next step was to find the carbon that would be the reactive site. So it would be the carbon that's attached to the double bond. And now you have to look at the difference in electronegativity. So it is this CN bond that's going to break, and this will therefore be the leaving group. And because the nitrogen is more electronegative, it's going to grab those bonding electrons when it goes. And if it does, it forms NH2 minus. Now, you may not have come across NH2 minus because it's such a strong base. Ammonia, weak base, but NH2 minus, strong base. So it's a very poor leaving group, because the moment we break it and it comes off, it'll want to attack and go back again. Not very stable at all. For carboxylic acid, that will be our leaving group. And again, our oxygen is more electronegative, so it's going to grab those bonding electrons when it goes. And therefore, the OH minus is strongly basic, but it's not as strong as NH2 minus. So it'll be a better leaving group than in the amide. And therefore, the carboxylic acid is more reactive than an amide, because it's easier to remove the OH minus. An acyl chloride, that breaks even more easily, because when that breaks and the electrons go to the more electronegative chlorine, we're going to form Cl minus. That's neutral. Think of NaCl. Cl minus is not going to attack that carbon, and therefore it is quite a stable leaving group. It's a good leaving group. So acyl chlorides are very reactive. Now finally, just think again of, why did we break the bond over here in each case? It's because that CR or CC bond is really strong. It's nonpolar, or pretty much nonpolar. So you are not going to break it very easily there. Always look for the most polarized bond first. Kia ora.